are here, hopefully, to hear Dr. Gary Small. And we are all thrilled to have him here. In case you didn't read his bio, he's professor of psychiatry and biobehavioral sciences at the Geffen School of Medicine at UCLA. His research has had him published in over 400 scientific publications. He's made headlines in the Wall Street Journal and the New York Times. He has written 6 books, one book which will be featured tonight, iBrain, about how young minds develop, function, and interpret information in this digital world. He has been named one of the world's top 50 innovators in science and technology. He's appeared on the Today Show, Good Morning America, PBS, CNN, and most recently at the Horizon School.
Thank you so much for your warm welcome and all of you coming out tonight on a busy night and not doing Facebook and texting, taking a moment to have some face-to-face conversations. We were upstairs having a chat, a group of us, and it's just so clear how important these issues are to all of us as parents, as kids, grandparents, wherever you fit in. It's clear that the technology train is way out of the station. It's running down the track. You can't stop it. And so what I'd like to do tonight is just talk a bit about some of what I've learned about this and hopefully generate some conversation and some questions so we can all look at it with a little more insight and a little more perspective. So what I'm going to talk about is basically summarized on this slide. And the first point is that technology, this new technology, is changing our lives clearly, but it's also changing the brains. And a young person's brain is most exposed and actually most sensitive. And so we have kind of 2 generations, the digital natives and the digital immigrants. And instead of a generation gap, we have what I call a brain gap. And I see a solution to it. I see we can bridge that gap by upgrading the tech skills of the older generation and helping younger people with their human contact skills. So let's begin with this idea, and that is that our relationship with technology is very personal. And to demonstrate this point, I want to do an experiment with all of you. And this is one of the few experiments I can do being a UCLA professor without having people fill out a 22-page form. So I love this one. And you don't have to participate if you don't want to. I encourage you to do it. And what I'd like you to do is to, hopefully your smartphone is off or on vibrate, and I'd like you to turn it on. And just as you turn it on, ask yourself how it makes you feel. And think about psychologically how it makes you feel. I know, I've had phone calls from people, that are freaking out because the server's down. Or even happened to me. Not long ago, my wife and I, we went out to dinner, and I forgot to bring my phone. I had kind of a moment of panic. But it was a much more enjoyable evening. I noticed things more. I was a little bit behind on my Words with Friends game. So I think we're kind of, okay, so hopefully you turn it on, and generally the feeling is a positive. We're connected. You might get that new email. I heard somebody, Bing going on. There's this thing, I don't know if you've had this, the phantom vibration. You think it's right, but it's not. So we're so programmed. So that's a positive. That's the good part of the experiment. Now here's the hard part. What I want you to do is take your phone and swap it with someone preferably you don't know. Now, I just want to reassure you. I'm a board-certified psychiatrist, so if anybody has a panic attack, this is the hard part. Smart guy. Exactly. Hopefully your phone is not being injured. Now here's part 3 of the experiment, which is really kind of the theme of this talk. I want you, if you can, if it's possible, to turn it off. Maybe even put it on vibrate. I'm sure there might be some emergencies you have to attend to, that's okay. But I think that's one thing we have to learn how to do. We have to learn how to unplug from the technology. It's very important. So let me put forward my arguments and why I believe this is what's going on with this. You know, our brains are very sensitive to input from moment to moment. Many experiments have shown that. So if you're looking at a computer screen, if you're reading a book, hopefully this book, or you're looking at someone's facial expression, that's going to trigger a cascade of events in your brain. So, for example, if you look at the visual input, and the light comes into your eye, hits the back of the eye, the retina, the information is transformed into little packets, and it travels along neurotransmitters, and it's very complex what's going on in the brain. And we're sort of born with this template. It's a bit like a computer. You get your computer, and there's lots of different functions that are outlined. You can see there's an organization in the front of the brain. It's kind of a thinking brain. Underneath the temples, the temporal lobe does a lot of memory. Back of the brain is vision. And what's remarkable is this thing only weighs 3 pounds. So it's tremendously complex. There's billions of synapses, little connection sites between our cells. So there's a lot going on in that little organ. And it's not only complex, but it's very specialized. So here's an experiment done a number of years ago with a PET scanner. The PET scanner allows us to see, stimuli in the brain. We actually use functional MRI now. It's a better way to do that. But in this experiment, they had the subject either listen, hear a word, or say a word, or think a word, and you can see very different parts of the brain are activated depending on how that information is processed. So you might perceive an image, or it stirs up an emotion, or maybe it jogs a repressed memory. Did I see you at Woodstock? Everybody here went to Woodstock. Or it could be an automatic response, knee-jerk response. And all this is going on in these neural networks that here looks like a plate of spaghetti, but it isn't. It's really quite remarkable. And we know from multiple experiments with PET and functional MRI and EEG, we can really trace everything that's going on. And we read about it in the newspaper all the time. Functional MRI scan used as a lie detector test, where we pinpointed the empathy center of the brain. So it's really a very remarkable time in terms of understanding what's going on in our minds and what's going on in our brains. Another point is that the brain is very plastic in the sense that it's quite malleable. It's changeable. It's very responsive, again, like a computer where you have these built-in macros. But what happens, and this is an important part of my thesis, and we know from neuroscientific studies, if you stimulate the brain over and over again with a certain mental experience, the neural circuits that control that experience will strengthen. On the other hand, if you ignore experiences, the neural circuits that control that experience will weaken. And we have the young brain, which is more plastic and more malleable than an older brain. We know kids are great with languages, and learning musical instruments, but there's a downside to the young brain. We were actually talking about this a moment ago. And one thing is that the frontal lobe, the thinking brain, the part of the brain that is engaged in complex reasoning, planning skills, is not fully developed in a young person. And, this might be an argument why teenagers probably aren't ready to drive. I know when I taught my daughter to drive, I think my hair was a lot darker before I started. It was a little bit, look out for this and that, and whatever did I get to. So the planning skills were not quite in place. Also, I put down the amygdala there. That's underneath the temples. It's sort of the emotional center of the brain. And we know that empathy skills, the ability understand another person's emotional point of view is not as good in a teenager as it is in a middle-ager. And so there's a question with all this technology exposure, how will that affect these young developing brains? And another concern is, you see this animation from Arthur Toga's lab from a few years ago. Actually, Arthur Toga and Paul Thompson deserted UCLA, went across town to USC. Long ago, you might have read about me all the times. Just in terms of transparency, I went to UCLA as an undergrad, but I went east to medical school. I did go to USC. So, but what they found here, what they're showing here, is that there's a process called pruning from birth well through adolescence. And what it means, it means what it sounds like. And that is that 60% of these synaptic connections in the brain are literally pruned away. So this idea of use it or lose it in the older brain is probably even more true in the younger brain. Now, what does this have to do with brain evolution? Well, we know that as we have advanced as a species, our brains got bigger, especially the front part of the brain. And there have been major milestones in brain evolution that have kind of moved the process forward very quickly. And one big one was the invention of the handheld tool. To think of taking a rock and making it into a weapon or a tool involves planning skills. And with that invention, there was coevolution, and there was a rapid increase in the size of the frontal cortex, the prefrontal cortex. And we saw at the same time more complex social networks as well as grammatical language developed at the same time. So in evolutionary years, this all went very quickly. Now the question is, what will happen as a result of this handheld tool? How will that affect evolution? And I think to speculate about the answer, we might turn to Charles Darwin and principles of natural selection, that a genetic variant that adapts best to the environment is most likely to survive. This explains the tremendous variability we see among species. So this is the environment our brains adapted to hundreds of thousands of years ago when we were developing language skills and face-to-face communication. Here's some of what the new environment looks like. Now, how will this affect us as a species? And here's one artist. Probably this person will have really big thumbs for texting. So this brings us to this generation gap in the digital natives. You know, young kids today were born into technology, using it 24/7, really good at it, and that's great. I think we all love the technology. Our brains really like it because our brains crave newness, so we can explore and do all kinds of wonderful things. The downside is they're not learning human contact skills. They're not looking you in the eye in a conversation. They're not noticing the emotional content or the expression, nonverbal cues. My daughter, when she was 17, I remember I said to her once, you know, Rachel, when I'm talking to you and you're texting at the same time, I just don't get a sense that you're listening. So she kind of looks up and says, don't worry, Dad, I don't do this with my teachers. So it's really hard to stop. And I know many of you have younger kids, and in some ways it's easier, in some ways it's harder. It's easier in that you can control it more. When they get a bit older, we can talk about how to deal with that and the different strategies to deal with it. It's in the media all the time. Here's an article about multitaskers. Don't read this in traffic. There's someone who said, if you're texting and walking, hold your chin at a 45-degree angle so you don't walk into a tree. And in London, they actually have pads on some of the poles so you don't injure yourself. So there's lots of problems, and there's lots of humor about it. There's a question about, can we get addicted to technology? I was just in Istanbul last week at the International Congress on Technology Addiction. A lot of people there from all over the world. The American Psychiatric Association has not classified it as an addiction. They put it into the category of obsessive compulsive disorders, but regardless of what you define it as. I'm convinced there are some people where it's problematic in everyday life, and I suspect that it stirs up the same primitive reward system in the brain, the dopamine reward system, that is involved in any addiction. And you know, if you think about the technology, all it's doing is supercharging everything that is human. So I mean, you can get addicted to shopping. You know who you are. Gambling, you name it. There are virtual games. Some people play Second Life 12, 14 hours a day. So they have a better version of themselves online. Who wouldn't want to play that? But it's disruptive. So now you may think, well, you know, I kind of like dealing with this technology, but I'm not addicted. And that may very well be the case. But one thing that kind of lures us in is this idea of operant conditioning, the psychological principle that behavior is reinforced by its consequences. So what I mean by this is if you take this sad face to represent the emotional reaction to an average email, I mean, that's, you open up an email, it's spam, or it's an uncomfortable task, or another boring email, and you're just about ready to give up email, and you get one of these. It's a happy face email. It's really great news. And because of that one happy face email, you just keep checking and checking. It's a very powerful reinforcer, much more powerful than if it was a happy face. Now, what about, is the environment really changing? So, the Kaiser Family Foundation has been tracking how much kids or young people from age 8 to 15, how much they're using the technology. And just by show of hands, how many of you think it's about 6.5 hours a day of content? 7.5 hours? How about 9.5? So it's really, the answer is 10.5, about 10. So that's a lot of time that you're using these devices. And I kind of think, I'm not a digital native, but boy, I'm spending a lot of time on my computer as well. Now there have been some studies looking at internet addiction and depression. Here's one study where they classified about 1% of the subjects as being addicted. And the internet addicted group had more depression. And, you know, it's hard to say, is it the cart before the horse? I mean, are people depressed and that's why they're drawn to it? Or is it making them addicted? We don't know. But this study found that there are differences in the brain in those who are defined as addicted. And areas of the brain that were different were the thinking brain, the frontal lobe, and part of the brain that controls memory. You know, what about this idea that the technology somehow interferes with human context? Here's an interesting study that was in a journal called Aggressive Behavior. I'm still looking for the journal Passive Aggressive Behavior. But what they did, and I think they published it, you'll see why, because of this particular study. They had about 200 students, ages 17 to 23. And they had them look at a neutral facial expression. And then the face either changed to an angry face or a happy face. And then they timed them to see how quickly they could recognize the emotional content of the expression. When the participants played a violent video game before they did the task, they lost their happy face advantage. Just one bit of evidence that they're going to be, you know, these systematic things. Now, I mean, as parents, I think we've all seen this. Many of us have seen it in our kids. I know that my son was particularly sensitive to it. He played too many video games. He would get kind of grumpy. And, you know, to punish him if he wasn't doing something, we'd kind of pull him off the computer, and he was a human being again. But it's very complicated. You know, I remember one day I heard him playing one of these violent video games, and I was concerned, you know, this principle, kind of keep doing that over and over, and it's not going to be good for you. So I heard myself shouting at him, "Harry, get off that video game and come downstairs and watch television." I thought, what am I thinking? Well, I was thinking that, we could talk it as a PBS show, we could talk about it. And there is something about this. I remember once when the kids were, I don't know how old they were, but the internet was down, of course, everybody was freaking out. But we went and we just kind of found a movie, and we had some popcorn, and we all watched a movie together. It was great. It was much more socially interactive and fun. What happens, you get kind of this parallel play, and everybody's on their device and they're not interacting. And it doesn't take a rocket scientist to figure out that if you're sitting in front of your computer all day, you're not out there exercising, so you have correlations with weight gains, and there's going to be all kinds of problems as a result of this. And I'm a big fan of physical exercise, healthy diet, healthy living to protect your brain health. Attention deficit, big concern a lot of us have. There's been a lot of studies showing a connection between screen time and worse symptoms of ADHD, grade point averages. And again, the cause and effect has not been completely figured out, but I think it's enough of a concern that the American Academy of Pediatrics recommends no screen time for kids under 2. They're kind of harsh. Not all pediatricians agree with that. And then that gets us to the digital immigrants. Many of us are in this generation where we kind of grew up in a time where you'd have more conversations. There wasn't all the technology everywhere. And so we're more, we're not used to the pace of innovation. We kind of like stuff like this. And if you think about, I think about the innovations in my childhood and lifetime. Color TV, that was one family had it, went down the street and watched it. And then, my God, you could erase on a typewriter. That was amazing. When we first wrote our grants, we would literally cut and paste, to get the grant out and make it work, and telephones. And then, of course, those first mobile phones. So cool, you have the suitcase and then video games. It's really come a long way. And there's a lot of debate about whether this is having a negative impact on how we think, and whether it's making us less thoughtful. And in a way, I would argue that it's what our brains do. We learn sort of a staccato quality of thinking. Like we jump from idea to idea, just as we jump from website to website. I remember a few years ago, I upgraded my phone, and my wife Gigi said, "Can you get that phone? Why don't you find out where that restaurant is we're going to tonight?" She went in the other room. She came back about 10, 15 minutes later. Said, "Well, where's that restaurant?" I said, "What restaurant? Look at this cool website." So we kind of get lost in the searching, and we're not really problem solving or being thoughtful. Now, we know that as people get older, they're more reluctant to use the technology. This particular study shows that. And just by show of hands again, how many of us here say check our email 3 to 5 times a day? Probably more than 5 to 10 times? More than 10? Who's checking it right now? It's a constant thing. And people expect that. If you don't return the email within 12 or 24 hours, it's seen as rude. So we kind of adapt new cultural norms. And you certainly see it quite a bit with young people. You'll see them on a date, and yet they'll be checking their devices or doing texts. And they don't think that's rude, whereas maybe an older digital immigrant might. And then there's the issue of multitasking and how it can be an efficient process. Now, I don't think I have it in the slide yet, but there was a study about a month ago. You might have seen this up at UC San Francisco. They had a number of people ranging in age from their 20s to their 80s play a video game. It was essentially trying to keep a car in the center of a winding road, and then they brought in these distractions, these signs, and you could train on this game to get better. And they found they could train very quickly an 80-year-old brain to perform like a 20-year-old. So, the technology's not all bad. I mean, there are things we can do with it that will help us with the digital clock. And we know as the brain gets older, it becomes more and more a challenge. At UCLA, we've done these studies showing how there's a buildup of Alzheimer's in all of our brains. Those are very gradual. And so by age 45, you can detect cognitive decline in the average person. So, it's in the press. Is Google making us stupid? So anybody who's a digital native, let me just point out that stupid is misspelled. And so at UCLA, we wanted to find out if Google is making us smart. And I was particularly interested in finding out what the brain looks like the first time it searches online. And so I quickly learned to recruit subjects for the study. I could not recruit them online. So I found people like this. Congratulations on the last person I heard. That was probably the hardest part of the study. But we did find about a dozen people, they tended to be older, who had never searched online. We matched them up, same age group and educational level, with people who had internet experience. We put them in a functional MRI scanner so you can see where the brain is working from moment to moment. We had them wear goggles, and in these visual goggles, we could have them read a simulated book page, or they could search online. They had a little button that served like a mouse. So we could do this experiment and see what was happening to their brains. So here's what we saw. And the colored areas show you where their brains were working. So these were the internet naive people who were reading the book. And there were some areas of the brain that you'd expect were activated, like visual cortex, thinking brain, memory. But not a lot of activity. And so the first time they searched online, there wasn't any difference. They were disappointed. And when the internet savvy people read the book page, same pattern. But here was a big payoff. When the internet savvy people searched online, their brains were having a big party. They were going crazy. So here's your brain on a book, and here's your brain on Google. Now the media interpreted that Google was making us smart. We didn't really find that. But we did find when we took those naive people and we had them search online for just an hour a day for a week, there were significant increases when we repeated the experiment. So I think what happens when we're unfamiliar with the task, any mental task, our brains are kind of firing randomly. When we figure out a strategy, then our neural circuits get working together. And once we get good at it, we actually see less activity. So our brains become efficient. And there's a lot of companies that are trying to deal with this concept. And you can, I guess Neuroscience is millions of people doing that, playing brain games. There's a study that found that you could play a game and improve what's called working memory, very short-term memory that you use to solve problems. And if you train on this game, your fluid intelligence actually improves. So the part of your IQ that solves problems gets better. So if we find the right games and the right tools, we can make people smarter to some extent. Actually, I did have a slide. Here's a slide that talks about this new study of this game. They called it Neural Racer. So you have to keep the car in the middle of the road, and they distracted people, and it had a very compelling effect. So now other people complain that technology is worsening their memory. They don't know phone numbers anymore. And the first thing I tell them is don't worry about your memory, because if you worry about your memory will be worse. You'll be distracted. And also pick and choose what you commit to memory. You don't need to remember phone numbers, but you need to remember names and faces. And you can teach people ways of remembering. So we can use our kind of external hard drive to augment our memory, our biological hard drive. Pick and choose. Surgeons who play video games make fewer errors in the operating room. So it's clearly doing something with hand-eye coordination and visual spatial skills. And It's something to keep in mind the next time you have elective surgery. Instead of looking at the diploma, are you from Harvard? How many hours a day do you play World of Warcraft? And we also know offline training has an impact. We've done studies of different forms of psychotherapy. We've done a lot of studies looking at healthy lifestyles, how it alters brain. So let's talk a moment about the future brain before we get to some questions and some discussion. It's interesting that there are now brain-computer interface devices, essentially kind of EEG monitors, that allow subjects to operate a computer just by thinking about it. Many subjects can type 15, 20 words a minute. And so, I think what's going to happen in the future, I really think that eventually it's going to be kind of chips that will be implanted in our brains. So, now we have Google Glasses, but, why want to go that direction? I don't see why not. There's actually, a few years ago, one of the first game companies had these head devices so you could play your video games just by thinking. So in the future, if you want to have a cup of coffee with your friend, you'll have this headgear on, you'll think about it, that thought will be transmitted by Wi-Fi to your friend. And you'll think, yeah, I'll meet you at Starbucks, and you can kind of sit there and sip your cappuccino, and you don't even have to talk, you can just read it. The downside would be you won't be able to walk down the street without some kind of tinfoil hat because you'll be bombarded by all kinds of advertising. So can computers read our minds? And according to one study at Carnegie Mellon, the answer is yes. So they did this experiment where they programmed the computer. If you were thinking about a celery stick or an airplane, the computer could figure that out. So it's kind of an interesting time. So what's the answer to all this? I think we don't want to give up our devices. I don't think we will be able to do it, but I think we need to find balance. We need to, again, upgrade these tech skills of older individuals, bring them up to speed, and help younger people improve their social skills. When I give a talk like this to college students or high school students, I will do an experiment from my book iBrain. I'll force them to turn off their devices, pick a partner, and one person will be the speaker, the other person will be the listener. The listener maintains eye contact, they don't say anything, they just try to listen. And it's a very compelling experiment. They can only tolerate about 30 seconds or a minute of it, but they realize there's something going on offline. I heard the comedian Louis C.K. kind of commenting on this. And I've seen this, my kids' recitals and everything. Everybody's like recording, the experience. And he said, well, put that down for a moment. It's really high definition if you just watch it. And we've got to innovate with the technology. And we've got to think of how we can use the right kinds of content. It's complicated. It's not that the technology is good or bad. It depends on the context, depends on the content, depends on how much we use it, whether it's helpful or not. And one thing that can be an innovation is combining physical exercise with some of the mental exercise that some of these programs offer. You want to find time offline, which is always good to read, spend time with friends, with nature. So the point is to try to manage the technology to preserve our humanity, not let it be other. So just to wrap up, I hope I've convinced you that this technology is not just changing our lives, it's having an impact on our brains. We've got a new generation gap, but we shouldn't give up hope. I think we can bridge the gap. There's a lot we can do. Picking and choosing when to use the technology and when not to use it. If you want more information, here's my website. And thank you again for your attention. So, as you know, I'm a big fan of conversation. So at this point, those who are interested, if you have any questions, maybe you could raise them and we can have a conversation.
So one thing, you talked about the frontal lobe not being developed in kids too much, and that's the organizational thing. So in elementary school, the desire of many of the teachers at our school is to learn to be a little more organized. And I'm wondering, is technology something that can help with that a little bit? Because, you know, like folks are going onto e-books and stuff and kind of managing their homework and all that. It's difficult to write down the notes and then remember which class to go to and all that stuff. So.
Yeah, I think it's a mixed bag. I think one could argue that some of the technology is improving organizations, because even some of the complex games are improving frontal lobe skills. If you look at some of these games, you've got to remember that this prize is in this room or in this city that was there a long time ago. And so you've got to hold that information in mind. It's building working memory and frontal lobe skills. So one could argue that maybe it's enhancing frontal lobe skills, or at least some skills. I mean, the frontal lobe is a big lobe, and when we do neuropsychological testing of older people who are getting forgetful, or NFL football players who are having problems, you know, some frontal lobe skills are better and some are worse. You know, impairment in visual spatial, but okay with executive function. So I think it's a matter of discussion.
Is there anything to that talking point that's floating around that when you buy video games make people in the environment?
Well, that's probably been one of the most studied things. So the question was, does playing violent video games make people more violent? And some studies say yes, other studies say no. So I think it's still something that hasn't been tuned down.
Is there a truth to dividing the type of screen time, meaning if they're playing Minecraft versus programming versus watching, in terms of sort of monitoring your children, can you categorize the technology and how it affects them differently? Like, if they play Minecraft for 2 hours, it's very different than if they play shoot 'em up.
Yeah, I think that, so the question, did everybody hear the question about?
No.
So the question is, does it make sense to kind of shake things up a bit? We play Minecraft for a couple hours, maybe we should do something else. I think as a basic principle, it's a good idea to change things up. No one studied this systematically.
But is there a difference in the effect on the amygdala and brain based on what they're playing?
Well, I think I would speculate yes and no. Depends on what the game is, depends on what the content is, depends on how long you're playing it. So there's a lot of different things. And if you look at the studies on working memory, these research subjects who had improvement in IQ were those that got better at the game. So if you play a game and it gets to be really, I always say train and don't strain it. If you can kind of make it continuously, make it challenging, it's probably going to exercise your brain more. So I'm an advocate of changing things, and our brains like change. So when I talk about brain games for older people, I say, well, kind of cross-train your brain like you do at the gym. So you do some left brain logical games, and you do some right brain visual spatial games. Other questions?
Do you have any recommendations for how much screen time children should have by age, maybe what time of day? Or
yeah, I don't have anything. I would basically, in terms of screen time, I think in this day and age, less is more. I think if we can kind of get kids off the screen, that would be good. We just did a study with the psychology department on this topic, where we kind of sort of from screen to group, getting kids off of the technology, how it affects them, and submitting that to publication. And it's clear that we've got to kind of monitor this and help our kids not to spend too much time on it. This is very difficult, especially with young kids. There's a lot of media. Instead of coloring books, we're using iPads, and the kids are drawn to it. They really like it because their brains like it, and it's fun and it's different. Yeah.
I guess this is kind of finding out the question that
2 hours of researching a topic but on a digital device, is that going to be the same as playing a video game on your brain? Are the effects that you're seeing
No,
in
it's
some of
got to
these
be
studies?
different. It's got to be different. If you could, I mean, if you read an ebook, it's going to be a different kind of mental experience than shooting up one question. So the technology is very different. And, I think this is the problem we face, is we're sort of using it willy-nilly, we're not using it thoughtfully.
And in these studies that you quoted here, when they talk about the time that the people are on screens or digital devices, are they defining it just as any time, or are there specific types of things that they're...
Yeah, what they do in those, if you look up Kaiser Family Foundation and you get the stuff online, you know, they break it down, the number of hours of TV, number of hours of different kinds of devices. And a lot of the time it's actually multitasking. There's more than one device.
With some of the technology out there, like Netflix, where you have thousands of titles of TV and movie shows at your fingertips, and games, there's hundreds and hundreds of games, and internet, there's just, everything is right there at your fingertips. And are there any studies that have shown the effects of that in terms of children's instant gratification? You know, they can sit there and choose anything they want, and they expect it to just be there. They expect, hey, I'm going to get a lollipop because I want it. The instant gratification. Have there been any studies that show effects of that?
I don't know of systematic studies looking at it, but I think we've all seen it as parents. There's a tendency for kids to feel like, I mean, look, it happens to me. I was just talking about how I really want to get up and put this DVD in the machine, download that. And so, you know, and there's a problem with overshoots. When you think of Netflix, there's all this content. You know, our brains sort of shut down. It's like when I go into Jerry's Deli and see that big menu, I have to just order the same thing. So, in fact, I've been to meetings. I remember a meeting with Google, and some of the people were saying that, you know, in the future, the real important technology will be the filtering technology. How to make sense of all this information. And it's ironic because all this digitized stuff is a way of making it easy to deal with so much content, to make it simple. Of course, thanks to our human brain, we just want more and more realization.
So, you know, my wife and I have the conversation a lot about, you know, you talked about a little bit the no screen time before 2, and I'm pretty much down with that.
That's exact cocktail hour.
So what happens if you at 1.5 show him TV? Like, what is the problem exactly?
Well, you know, yeah, and it's, you know, my grandmother thought that TV was going to rot my brain.
See, it was my babysitter, so you know, I was raised a lot differently.
Yeah, so I think, you know, there is something to that, and your brain is resilient, and you can rightly be treated right. And I think where there may be actually evolutionary change is if we don't like it. In the future, we may look like a cartoon. So, you know, I think it's really a matter, since there are no specific guidelines, the guidelines you hear about seem to be a bit arbitrary. I think it's up to us as parents to kind of come up with reasonable rules. I mean, no technology before 2 minutes. I mean, in our house, there's no tech at dinner. You know, we're going to force you to have a conversation. So I think each family has to deal with it.
Has there been any study on how screen time affects vision, especially because there is on the watching screen for hours and hours? And, you know,
Yeah, I don't know. That's a good question. I don't know what that studies, whether excessive screen time harms visual acuity.
I'm just, for me, one of the things we've done is we limit our boys to the weekend only for television, video games, computer time, 1 hour Friday, 1 hour Saturday, 1 hour Sunday.
How's that working for you?
hard, no, we did it after our oldest, who's now in the 7th grade, was in 2nd grade. And 1 week of hard time, and after that, it's okay, they had to live with it. There was no way we were going to not do away with it. And they are really big readers.
That's fantastic.
And so it was hard initially, but I think it was the right thing for us to do. The issue now we deal with is the 7th grader has a smartphone. And what he has to do when he comes home from school is he has to give me the smartphone until he finishes his homework. And because what he would do is, interact with his friends all the time. So it's been an interesting time for us because parenting, we really have to parent.
It's tough, and as you say, as the kids get older, it's harder to monitor.
Yes.
I know, I would always complain to my son, it's too much technology, you're not reading enough, and this was about the time when iBrain came out, which was really not written for his age group. And he said, well, I'll show you, I'm going to read this book to you. And he read from cover to cover, he did all the exercises, and at the end he said, Dad, I think I'm better at conversations now. So I think it is possible to help the kids and kind of teach them that there is a world outside of their screen.
Is anyone studying the effect of companion animals as an adjunct to social development and social interaction and figuring out the others?
So companion animals.
Cats, dogs.
Yeah, I'm not that familiar with that research, but I know it's, they have them in a lot of hospitals, and it's, really can help individuals feel better. And there's actually a recent study that's quite interesting. You know how yawning is contagious?
Yeah.
They found that actually your dog
Yeah.
can kind of pick up on your yawning. So there is kind of an empathic experience with the animals. So why don't we, I know it's a school night, so why don't we stop here and kind of continue the conversation amongst ourselves. Thank you again for your attention and